Hi guys, we're doing this math paper today. This is 9701, paper 1-2, May June 23. So this is actually the first paper in the May June 2023 series. I'm going to be releasing more soon, hopefully planning to solve all of them by January, math and science included. So before we begin, let's take a look at the threshold. Surprisingly, it was very low this year. We're actually doing paper 1-2 first. A was at 49 actually. Paper 1-3 was easier, but paper 1-2 and 1-1 were a bit harder than usual. So full marks is 75. A was at 49, B was at 40, C was at 30, D was at 20, and E was at 10. So A star was probably at around something like maybe 9 to 10 marks above 49. So maybe 58 or 59, which is very low. I haven't seen that in a long time, and coincidentally, this threshold was even lower than the P3 threshold, which makes it even weirder. So let's begin. Also guys, if you like the content, please do subscribe to the channel and consider subscribing or supporting me on Patreon. It's patreon.com/CAIE paper solved. There are plenty of tiers, but with the highest tier, the $15 one, you get access to a video meeting with me every month where we can discuss your problems. Without further ado, let's begin. The equation of a curve is such that dy by dx is equal to 4 by x minus 3 whole cube. For x is greater than 3, the curve passes through the point 4, 5. Find the equation of the curve. Okay, so we are going to integrate it. Why is it x greater than 3? Because if x was less than 3, then this value would become, oh, it's for this particular question, but x can't be 3, by the way, okay? Because if x is 3, it becomes 4 by 0, which is infinity. Okay, so let's integrate it. 4x minus 3 to the power minus 2 divided by minus 2 times 1 plus c. So we can actually simplify this. It is minus 4 by 2 times x minus 3 to the power minus 2 plus c. Or we end up with 4 is equal to minus 2 x minus 3 to the power minus 2 plus c. Now we have a particular coordinate which is 4, 5. With the help of this, I'm actually finding out the value of c. Good. So at the end, we end up with y is equal to minus 2 divided by x minus 3 whole square plus 7. This is my final answer. Okay. The coefficient of x to the power 4 in the expansion of x plus a to the power 6 is p, and the coefficient of x squared in the expansion of this is q. It is given that p plus q is 276. Find the possible values of the constant a. Okay. Let's break this down. So what do we end up with? 62 is 15. On the other hand, ax plus 3 to the power 4 is what coefficient do we need? X squared. 4 times 3 is 12. 4c2 into 9 is 54. So the coefficients are particularly this one and this one, x to the power 4 and x squared. So p is essentially 15a squared and q is 54a squared. So we know that p plus q is 276. So 276 by 69 is 4. So they said find the possible values of a. So a can be plus minus 2. Okay, moving on. Please do comment below if you have any queries. It's pretty straightforward. Completing squares. Okay, let's do this step by step. You can see that we've taken a value common here. So it's 4x squared minus 24x plus p, or 4x squared minus 6x plus p by 4. Okay, now let's begin. This can be written as x whole square minus 2 times x. What do we need to make this 6? We need a 3, right? 3 to the 6. Then we give the plus sign, and now since we have this 3 over here, we have to write 3 square, and since we introduced a 3 square, that is not mathematically sound, so we need to subtract this as well. And as usual, we have p by 4. Next step, we can write this as x minus 3 whole square minus 9 plus p by 4, and if we break down the bracket, it's 4 x minus 3 whole square minus 36 plus p, or we could write it as this. Now express them where a and b and c is to be given in terms of this, so we can write it as, a is 4, b is minus 3, and c is p minus 36. Hence or otherwise, find the set of values for which this equation has no real roots. So for no real roots, we know that b squared minus 4 is c. The roots must be imaginary or less than 0. So we can just input this over here. 4x minus 3 whole square plus p minus 36. There are two ways to do this. One is b squared minus 4ac root, and the other is, what is this? Since x squared is positive, this is actually a minimum curve, right? The curve is minimum, and what is our minimum point? It is p minus 36. So our minimum point happens to be when x equals to 3, y or fx is equal to p minus 36. So this is the coordinate. Now we want this minimum point, right, at 3 and p minus 36 to be greater than 0, y 0. Why? because for imaginary roots, we know that our graph cannot cut the x-axis. So for that to occur, the value of y must be greater than 0. So how can we solve this? P minus 36 must be greater than 0. So P must be greater than 36. That is our answer. This is root number 1. If it was a maximum curve, then we need to write, P minus 36 needs to be less than 0. Next, b square minus 4ac root is less than 0. What is b? Minus 24. So minus 24 whole square minus 4 into 4, that's a, and c is p. 576 minus 16p is less than 0, or 16p is greater than 576. So p is greater than 36. Anyway, it works. It's up to you guys, okay? Moving on. These are the two ways. Moving on to question number 4. How many do we have in total? 11, okay. It's not going to take that long. Solve this equation. 8x6 plus 215x cubed minus 27 is equal to 0. So we know how to do this. We have to say let x cubed be a. So 8a square plus 215a minus 27 equals to 0. So if you put it in the calculator, 1 by 8 and minus 27. You should show the middle term breaking, or you can use a general formula if you want. 8 times 27 is 216. Okay, so this is 215, right? So isn't it pretty straightforward? I think this could work. 216a minus, a, plus 216a minus 27 equals to 0. Let's try doing this. So if I take 8a, I get a 216 by 8 is 27. A plus 27 minus 1, a plus 27 equals to 0, which is 8a minus 1 and a plus 27 is equal to 0. I know that the multiplication must be equal to 8 into 27, and the subtraction must be equal to 215. That's how I find this out. You could also use the general formula. It's mentioned in the mark scheme. Like you could go for, a is equal to minus b minus 215 plus minus root over b square, 215 square minus 4 into 8 into minus 27 divided by 2 times 8, which is minus 215 plus minus 215 square plus 4 into 8 into 27 plus minus. So one of them is 2 by 16, while the other is minus 215 minus 217 by 16 minus 27. Similarly, that is another root. Here I can directly get 8a is equal to 1, a equals to 1 by 8, or a is equal to minus 27. So a, we know that it's x cubed is 1 by 8, so it gives us an answer x equals to half cubic root. And here we know that x cubed is equal to minus 27. We can cubic root negative numbers, so we get a value of minus 3. So our two answers are half and minus 3. Moving on. Find the area of the shaded region. Diagram shows the curve with equation y is equal to 10x to the power half minus 5 by 2 x to the power 3 by 2 for x is greater than 0. Okay, let's do this. The limits are 0 and 4. 10x to the power half minus 5 by 2 x to the power 3 by 2 dx, 4 and 0. So that is 10 x to the power 3 by 2 divided by 3 by 2 minus 5 by 2 x to the power 5 by 2 divided by 5 by 2. Why don't I write this as 5x to the power 5 by 2 divided by 2 into 5 by 2. Limits are 4, 0. I don't see why the paper was hard though. It looks pretty simple till now. 20 by 3 x to the power 3 by 2 minus, we can get rid of this 5 as well, x to the power 5 by 2. So that is minus 0 plus 0. 160 by 3 minus 32. This is my answer, 64 by 3, or you could write it as 21 whole 1 by 3. Anything works. Number 6. Okay, so for number 6, show the arc length AB is 2x theta cos theta. So arc length AB, this is what we need to find out. S is equal to r theta. And we know that these lengths are equal. We also know that AOB is theta. We need the value of OA. So you can actually approach this using sine rule or cos rule, but it would be too complicated for AS level. So we can just go for this. You know that I can draw a right angle triangle here, and I can find out this length over here. And we also know that this length over here and this length over here are equal because it's an isosceles triangle, right? That is exactly why this is possible. So this value is actually r by 2, or we can call it half OA. So we can actually write cos theta equals to adjacent, which is half OA, by hypotenuse, which is x. So half OA is equal to x cos theta, or OA is equal to 2x cos theta. Now arc length is equal to s r theta, s equals to r theta. So we can say that AB is equal to OA times theta, which is 2x theta cos theta. Is that fine? It was a bit tricky. If you didn't know where to look at it, you didn't know the perspective. No? Find the area of the shaded region in terms of x and theta. So it's basically the sector area minus the triangle area. So what is the sector area? Is half r square theta, which is half times OA square, which is 2x cos theta whole square times theta. So that's half times 4x square cos square theta into theta, which is 2x square theta into cos square theta. And what about the triangle? That's going to be you could either approach it using half AB sine theta, but we don't have the angle in between. That's pi minus 2 theta, and you don't have compound angles in your formula. Like this angle over here is pi minus 2 theta, so you would end up writing half AB sine pi minus 2 theta. You do not know the formula in AS. It's in the booklet, but it's better if we don't use it. So why don't we find out the area of this right angle triangle, which happens to be triangle area is equal to half into base. The base is half times OA, which is x cos theta. Half into base into height. So what is the height exactly? we can write, sine theta is equal to opposite height by hypotenuse x. So height is equal to x sine theta. So half into base into height times 2. Because there are two right angle triangles, we can get rid of this. So x square cos theta sine theta. Now let's subtract it. Area of APB. 2x square theta cos square theta minus x square cos theta sine theta. Let's check. So we can actually take common over here. So we end up with x square cos theta, which is there are three things here. 2 theta cos theta minus sine theta. That's all. Answer 7. By first expanding this, find the three solutions of the equation. Okay. Cos square theta plus 2 sine theta cos theta plus sine square theta. So we know that it has sine square theta plus cos square theta, which can be written as 1 plus 2 sine theta cos theta. Now they want us to write cos theta plus sine theta whole square is equal to 1, or 1 plus 2 sine theta cos theta equals to 1. We can get rid of the 1. 2 sine theta cos theta equals to 0. How are we going to solve this? This can also, you can directly write it as sine 2 theta according to the identity. That is one route. Here, let me show you. One of the routes is this. 2 sine theta cos theta is equal to sine 2 theta. That's a root. But since you do not know that in AS, it's better if you don't. This is one route. Another route is doing it manually. So once we're gonna go for sine theta equals to 0, and then we're gonna go for cos theta equals to 0. So is it in degrees or radians? Okay, radians. So sine inverse 0 is alpha is 0 and pi minus alpha is pi. On the other hand, cos inverse 0 is half pi. So we get pi by 2 and minus pi by 2 as our basic acute angles. Now, the three solutions from 0 to plus pi. 0 is included. So what are our three solutions? There is no point adding 2 pi with minus pi by 2, because we actually get 3 pi by 2 as another acute angle, but that is greater than pi, right? So our final answers are theta is equal to 0, pi by 2, and pi. See if you get it. And if you use this, you'd get it directly. Hence verify that the only solutions of the equation cos theta plus sin theta equals to 1 are 0 and half pi. Okay. From 0 to pi. So let's try. So cos 0 plus sin 0. Cos 0 is in fact 1 and sin 0 is 0, which is equal to 1. Proved. Then cos pi plus sin pi is equal to cos pi is 1, right? Minus 1, sorry. And sin pi is 0. So we actually get minus 1. So that's not right. This doesn't work. And then cos pi by 2 plus sin pi by 2. Cos pi by 2 is 0. And sin pi by 2 is actually 1. So that also works, shown. So only these two work. So only 0 and pi by 2 satisfy the equation. This is not equal to 1, shown. Now prove this identity. Let's do it. Sin theta divided by cos theta plus sin theta plus 1 minus cos theta divided by cos theta minus sin theta has to be the same as the one on the right. So typically we start with LCM. Now let's begin. This sin theta on the top must be multiplied with these, so we end up with sin theta cos theta minus sin square theta. On the other hand, 1 minus cos theta must be multiplied with this on the left, the denominator on the left. Cos theta plus sin theta, I multiplied it with 1, then minus cos square theta minus sin theta cos theta. So we can get rid of this minus sin theta cos theta plus this one. So we end up with cos theta plus sin theta minus sin square theta minus cos square theta, and below we get cos square theta minus sin theta cos theta plus sin theta cos theta minus sin square theta. We can get rid of this and ultimately check this. We can get cos theta plus sin theta. I will take minus sin common, so we end up with sin square theta plus cos square theta, and below I have cos square theta minus sin square theta. I only require sin square theta, so we know that sin square theta plus cos square theta equals to 1. So cos square theta is equal to 1 minus sin square theta. So I can write 1 minus sin square theta minus sin square theta. So ultimately we end up with cos theta plus sin theta minus 1 divided by 1 minus 2 sin square theta. Shown. Okay. Using the results of A2 and B, solve this. Okay. So we know that this one on the left hand side is this, can be written as cos theta plus sin theta minus 1 divided by 1 minus 2 sin square theta. Yeah, this sum was a bit complicated. Now I get why some candidates were complaining about a hard paper. So I wrote the one on the left as the one on the right hand side is equal to 2 cos theta plus sin theta minus 1. Okay. Now what? We have to simplify this. We can actually do this. Check this. Cos theta plus sin theta minus 1. I'm cross multiplying. Okay. Is equal to 2 into cos theta plus sin theta minus 1 into 1 minus 2 sin square theta. Now I'm going to bring this one on the left hand side. So can I not write cos theta plus sin theta minus 1 divided by cos theta plus sin theta minus 1 equals to 2 times 1 minus 2 sin square theta. We end up with 1 on the other side. Okay. Now what? How are we going to solve this? You actually end up with half, right? So half is equal to 1 minus 2 sin square theta, or if I bring it on this side, 2 sin square theta equals to 1 minus half, which is half, or sin square theta is equal to 1 by 4. I don't have enough space for some reason. Okay, so we end up with this. Now what? So we get two solutions. Sin theta is equal to half and sin theta equals to minus half. So let's solve it from 0 to pi. So alpha is equal to pi by 6 and 5 pi by 6. Over here we get sine inverse minus 1 by 2. Alpha equals to minus pi by 6 and 7 pi by 6. So which ones are in our domain from 0 to pi? Only this one on the left hand side, pi by 6 and 5 pi by 6 over here. And on the other hand, minus pi by 6 and 7 pi by 6 aren't actually in the domain. But this was a rather trick question, because check this. Why did they mention using the results of A2 and B? We used A2, right? When I converted this identity over here on this side. But see, this is connected to B. How? This one. Check this. This equation could be written as cos theta plus sine theta minus 1 equals to 0. And over here, see, cos theta plus sine theta minus 1. We have that thing in common. Even here, look, we had that. Cos theta plus sine theta minus 1. It doesn't matter if you have a 2 up front. Check this. Even if you have a 2 up front, same. You are going to get two solutions, 0 and pi by 2. So if you solve it this way, we are going to miss two solutions. So ultimately, what are our answers? Pi by 6, 5 pi by 6, as well as 0 and pi by 2 from the previous part over here. So yeah, this was rather complicated, but they did tell you that you needed to use it. So these are our four answers. Please do check this out again. Pretty complicated, right? And these ones on the right are invalid, because you know these are outside the domain, right? So these are our four answers. Okay, they did give you a hint before. Let's go to 8. We don't have much left. 8, 9, 10, 11, 4 questions. On the diagram, sketch the graph of f inverse x. So let's draw y is equal to x line first. So hard to draw it with the mouse. So this is my line, y equals to x. Now let's draw the inverse. So 0, a little bit before pi. So it's going to be a little bit before pi and 0. This point is common between them. And then check this one. At 2 pi, it's a bit more than 3 pi by 2. So similarly, the y value will be 2 pi at a bit more than 3 pi by 2, somewhere over here. What else? This point over here, at this point, you know, half box after pi, it is almost 3 pi by 2. So similarly, a half box after pi, it will almost be, see this half box after pi, it will almost be at here. It was almost at 3 pi by 2. So also here it will almost be at 3 pi by 2 in the x-axis. So yeah, somewhere over here, just almost there. So yeah, now let's just join the points. That's gonna be all. Something like this, essentially. Okay, that's all. Find an expression for f inverse. So let fx be y. Okay. sine 1 by 4x equals to y minus 3 by 2. So ultimately 1 by 4x equals to sine inverse y minus 3 by 2, or x equals to 4 sine inverse y minus 3 by 2. And ultimately, therefore, f inverse x equals to 4 sine inverse x minus 3 by 2. Okay, answer. Now, the diagram above shows part of the graph of the function gx. Complete the sketch of gx on diagram above and hence explain whether the function g has an inverse. So it's 3 plus 2 sine pi by 4x. So let's try to do this. If you just input random values, I'm going to input what exactly? These four. Minus pi by 2. I'm going to use my calculator. So at minus pi by 2 it is plus 2.23. At minus pi it is 3 minus root 2, which is 1.59. At minus 3 pi by 2 it is 1.15, and at minus 2 pi it is 1. So what do these values represent? 2 pi actually means 6.28. 2 pi, this value means 6.28. Okay, on the other hand, pi by 2 represents 1.57. This is 1.57. Pi is 3.14. Pi is 3.14. So essentially, think about it. Where is 2.23 gonna lie? What is the value in between this? That is 3 by 4 pi, right? 3 by 4 into pi. That is 2.35. This is 2.35. Okay. So 2.23 is just below 2.35. So it should be somewhere over here. Then 1.59 is just above 1.7. It should be over here. And what is pi by 4? Pi by 4 has a value of, 0.79. This is 0.79. So yeah, at minus 3 pi by 2 should be at 1.5, 1.15, which is somewhere over here. And 1 is somewhere over here. So essentially it's like a mirror image. Could you understand? Like if you continue these, join these lines, it's something like this. It's like a mirror image of the other graph on that side. So here you go. It should be something like this according to that. Wait up. It crosses this axis just after. Okay. It's so hard to draw. So essentially this is the graph, something like this. Would be easier if I had a pencil. Let's try to draw it in one line. Something like this. Now explain whether it has an inverse. So basically, to have an inverse, check this. This does not have an inverse because for like the one value of y, it repeats two times for two values of x. But here, look, all the values of y are unique. Not once does it repeat. This is the maximum point, minimum point, and it never repeats again. Think about it. Because after this point, after 2 pi, oh sorry, 2 pi is over there, right? I messed up. It should be something like this here. Now it should be better like this, yeah. There you go. So basically, yeah, this function does have an inverse because no value repeats. You can't have an inverse if your value of y occurs at two values of x's, but here every value of y is unique. It only occurs once for each value of x. So we say that yes, it does have an inverse. Why? Because it is 1 to 1. Because you could say the graph is always increasing, or it is 1 to 1. Or you could say it is not main to 1. Describe Fourier sequence of three transformations which can be combined to transform y is equal to sine x to the graph of y is equal to fx, clearly making clear the order which is applied. So what is y is equal to fx? It is 3 plus 2 sine 1 by 4x. So we are turning y is equal to sine x to this. Okay. So 6 marks step by step. A translation of 3 was added, but let's do this later to the whole function. Let's do it step by step, because if you do this first, then when you apply the stretch factor, vertical stretch factor, it will be wrong. So check this. Number 1, we will apply the stretch factor 4. Remember, anything you apply to x, it will be the other way around inside the function. So we apply a horizontal stretch factor 4 in x direction. So sine x turns into sine 1 by 4x. Next. So the benefit of doing it in the x-axis is it will be unaffected by other transformations now. Now we apply another stretch, but this time the factor will actually be 2 in the y direction. So it turns into sine 1 by 4x turns into 2 sine 1 by 4x. And last but not least, we're going to apply a translation of 0, 3 vertical direction. So 2 sine 1 by 4x plus 3. That's it. See if it makes sense. Now if you apply the transformation of translation first, see, if you did this 3 plus sine x, then you did this 3 plus sine 1 by 4x, that is also fine. But if you do this now, if you apply the vertical stretch factor now, it turns into this 6 plus 2 sine 1 by 4x, which is wrong. Do you understand? That's why you have to apply the translation after the vertical stretch, alright? Understood? Moving on to 9, 10, and 11. Last three. The second term of a geometric progression is 16 and the sum to infinity is 100. Okay, so we know that the formula for sum to infinity is a divided by 1 minus r. And the second term, t2, is a r to the power 1, right? That's the second term. So the second term is 16. 16 is equal to AR, and the sum to infinity is 100. 100 equals to A divided by 1 minus R. So 100 into 1 minus R is equal to A. Find the two possible values of the first term. So R is equal to 16 by A. So 100 minus 100 into 16 by A is equal to A. So that is 100 minus 1600 by A is equal to A. After LCM, 100A minus 1600 by A is equal to A, or 100A minus 1600 equals to A square, or A square minus 100A plus 1600 equals to 0. So let's use the calculator. 1 minus 100, 1600, 80 and 20. So can I write this? Oh, basically this. So A is equal to 20 or 80. I didn't find out the value of R though. In the mark scheme, they did find the value of R. That's not necessary. This one was also given. This is it. Okay. It's better to show the middle term breaking. Show that the nth term of one of the two possible geometric progressions is equal to 4n minus 2. So for this, you actually need the values of R, or else it's not possible. We know that R is equal to 16 by A. So R is equal to 16 by 20, or R is equal to 16 by 80. So we end up with 4 by 5 or 1 by 5. Now, show that the nth term of one of the two possible geometric progressions is equal to 4 to the power n minus 2 multiplied by the nth term of the other geometric progression. Okay, so we know that Tn is equal to a to the power a r to the power n minus 1. Now, for r equals to 4 by 5, the first term was actually 20. So this is for the first one. We can write 20 times 4 by 5 to the power n minus 1. And for the other one, the nth term was, the first term was 80 times 1 by 5 to the power n minus 1. Now what do we need to show? Show that the nth term of one of the two possible geometric progressions is equal to 4 to the power n minus 2 multiplied by the nth term of the other. Okay. So clearly, since this is smaller, and if you multiply 4 with 20, you end up with 80. This is probably possible. So you could show that 20 times that is actually equal to this. Or you could just simply do a ratio. That is also an accepted method. So one of the methods is this. For example, 20 times 4 by 5 to the power n minus 1 times 4 to the power n minus 2. Let's see where we end up. So I can actually take the 4 away. Can I do this? 20 times 1 by 5 to the power n minus 1 times 4 to the power n minus 1 into 4 to the power n minus 2. I just took the 4 away from 5. Both of them have the same power still. Now these 4s, what can I do with them? Check this. Can I write this as you know, but this isn't actually working out. I think it might be the other way around. It might be the other way around. Because if I try to do this, there's no way that I get, 80. Because check this. This can be written as 21 by 5 to the power n minus 1 into, I need this, 4 to the power n minus 1 times 4 to the power n divided by 4 square, which is 16. So I actually end up with 20 by 16. There's no way that I end up with this because I have this, right? But I need an 80. But my value is just becoming lower. So I don't think this is the correct way. I think it was the other way around. So since it wasn't working, I need to try it this way. 80 times 1 by 5 to the power n minus 1 into what? 4 to the power n minus 2. We're going to show that it is equal to the one on the left. So I can write this as 80 times 1 by 5 to the power n minus 1 times 4 to the power n by 4 square. Or I can write this as 80 times 1 by 5 to the power n minus 1 into 4 to the power n divided by 4 to the power 1 into 1 by 4. I just split one of those 4's. I took out the square and wrote it as 1 by 4 into 1 by 4. Now I can get rid of this. This and this can be reduced. That's 20. So 20 times 1 by 5 to the power n minus 1 into 4 to the power n minus 1, which can be written as, 20 times 4 by 5 to the power n minus 1 because they have the same power. So this is one root. That this nth term, one of the nth terms multiplied by 4 to the power n minus 2 gives you the other nth term, the one for the other series, okay? Tricky. The other root was just doing a ratio. That was method 1, this is method 2. Just doing a ratio simply. You could go for 20 times 4 by 5 to the power n minus 1 divided by 80 times 1 by 5 to the power n plus 1. Sorry, n minus 1, right? Now, this can be written as 20 times 1 by 5 to the power n minus 1 times 4 to the power n minus 1 divided by 80 times 1 by 5 to the power n minus 1. We can get rid of these two, and 20 by 80 is 1 by 4, so we end up with 4 to the power n minus 1 divided by 4, which is 4 to the power n minus 2 essentially. Okay, shown. That is another root. So this is the whole working. See if you get it. This is method 1. Last two sums then. Circle. Equation for circle is this. The line, this is the tangent. Show that one possible value of a. So for tangents, we know that b square minus 4ac is equal to 0. So I'm going to input this over here. X minus a whole square plus y minus 3 whole square equals to 20. X minus a whole square plus half x plus 6 minus 3 whole square equals to 20. So x minus a whole square plus half x plus 3 whole square equals to 20. Now what? X square minus 2xa plus a square plus 1 by 4x square plus 2 half 3x plus 9 equals to 20. 1 by 4 plus 1. How much is that? 5 by 4, I guess. 5 by 4x square minus 2xa plus 3x plus a square plus 9 minus 20 is minus 11 equals to 0. So now 5 by 4x square plus x 3 minus 2a plus a square minus 11 equals to 0. B square minus 4ac is equal to 0. Since it's a tangent, roots are real and equal. So b square 3 minus 2a whole square minus 4 into 5 by 4 into a square minus 11 is equal to 0. This seems a bit too complicated though, but I guess this is the way to go. So 9 minus 2 to the 4, 4 to the 12a plus 4a square. We can get rid of this. Minus 5a square plus 55 equals to 0. So minus a square minus 12a plus 64 equals to 0, or a square plus 12a minus 64 equals to 0. If we do solve this, we get a plus 16 and a minus 4 equals to 0. So a is equal to 4 and minus 16. We already had one answer. One of them is 4, the other possible value is minus 16. That is all. Okay. For a is equal to 4, find the equation of the normal to the circle at P. Okay. So we need to find the gradient of the... Wait. Tangent first, right? So for example, this is the point. We know that this is the tangent. So we need to find out the equation of the normal to the circle at P. So what's the equation of the tangent? Y is equal to half x plus 6. So what's the gradient of the tangent? Half. So gradient of the normal will be minus 2. And what's the center of the circle? For a is equal to 4. So that's x minus 4 whole square plus y minus 3 whole square equals to 20. So the center is 4, 3. Okay. So let's find the equation of the normal. We know that the normal must pass through the center, right? So we have the gradient of the normal as well as one of the coordinates, which is 4, 3. Because if you draw any tangent, okay, if you draw any tangent to a circle, its normal must pass through the center. Okay, that's a criteria. So y minus 3 is equal to minus 2, x minus 4, y minus 3 is equal to 8 minus twice x, or y is equal to 11 minus twice x. That is our answer. For a equals to 4, find the equation of the two tangents to a circle which are parallel to the normal found in B. Okay. So essentially we found a normal, right? Now we want to find out the two tangents which are parallel to the normal. Okay. So this is a rather interesting question and quite complicated, I should say. So let's get to it. Okay, so now how are we going to proceed? So basically what we can do is we can find out the diameter, the equation of the diameter, the one that passes through the center like this. We have the gradient of the tangent, we found the gradient of the normal, and we can use the gradient of the tangent again. I'm talking about this tangent over here. They'll match. The equation of this purple diameter and the pink tangent will match, and using the help of that we can find out these two tangents. I'll show you what I mean. So I know that the gradient of the initial tangent was, half. So the purple one will also be half. So this is the equation of the diameter. Y minus 3, excuse me, equals to half x minus 4. So we end up with 2y minus 6 equals to x minus 4. Or 2y equals to x plus 2. And ultimately y equals to x plus 2 by 2, or you could write it as half x plus 1. So what do I want to do with this purple diameter that I found out? I want to input it into the equation of the circle so that I can get the 2 points where the diameter touches the circle, so that I can get those green tangents, right? So that I can get those green tangents which are parallel to the normal we found initially, which are normal which are parallel to this normal that we found in part B. So the equation of the circle is x minus 4 whole square plus y minus 3 whole square equals to 20. Now I'm going to input y is equal to half x plus 1 inside. So x square minus 8x plus 16 plus half x plus 1 minus 3 whole square equals to 20. X square minus 8x plus 16 plus half x minus 2 whole square equals to 20, or x square minus 8x plus 16 plus 1 by 4 x square, 2 into half 1 minus twice x plus 4 equals to 20. So we end up with 5 by 4 x square minus 10x plus 20 minus 20, which is 0. So we can take x common, so that's 5 by 4x minus 10 equals to 0. So one of them is, in fact, one of the answers is x equals to 0, the other one is 5 by 4 x equals to 10. So x equals to 10 by 5, which is 2, 2 times 4, which is 8. So x equals to 0 and 8 are our answers, are the x coordinates. Now we need to find the y coordinates. So one of them will be y is equal to half into 0 plus 1, which is 1. The other is y is equal to half into 8, 4 plus 1, which is 5. So the coordinates are ultimately 0, 1 and 8, 5. Now finally we need the equations of the two tangents. So we know that their gradient is equal to the gradient of the normal that we got at minus 2. So let's find it out. So they are y minus 1 equals to minus 2, x minus 0, y minus 1 equals to minus 2x, or y is equal to 1 minus 2x. That's 1. What about the other one? Y minus 5 equals to minus 2, x minus 8, so that's y minus 5 equals to 16 minus twice x, or y is equal to 21 minus twice x. So y is equal to 1 minus twice x, and that one, 1 minus 5 equals to minus 2x minus 8, y equals to 21 minus 2x. So these are our final answers. So yeah, pretty difficult sum. I realize why the candidates were complaining now. Every sum had a difficult component, but till 5 it was pretty straightforward. Afterwards it started becoming a little bit difficult. Number 11, calculus, find dy by dx. So dy by dx equals to k times half 4x plus 1 to the power minus half times 4 minus 1. So we end up with 2k times 4x plus 1 to the power minus half minus 1. Really important. Next, find the x-coordinate of the stationary point. So for the stationary point, we know that dy by dx equals to 0. So 2k times 4x plus 1 to the power minus half minus 1 equals to 0, or 2k by 4x plus 1 to the power minus half equals to 1. It won't be minus half anymore. So 2k is equal to 4x plus 1 to the power half. So we can square both sides. So 4k square equals to 4x plus 1. in terms of k, right? So 4x equals to 4k square minus 1, x equals to 4k square minus 1 by 4. Okay, they just wanted the x coordinate. Next, moving on, last one. Given that k is equal to 10.5, find the equation of the normal to the curve. Given that k is equal to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse 2 with the positive x-axis. Okay, so we have a curve essentially. So given that k is equal to this, find the equation of the normal to the curve at the point where the tangent to the curve, suppose if this is a curve and the tangent to the curve makes an angle of tan inverse 2 with the positive x-axis. So what does tan inverse 2 mean? We know that uh, angle or dy by dx is basically the gradient. So since the angle theta is equal to tan inverse 2, we can say that tan theta is equal to 2. So always remember that dy by dx represents the gradient. It's the change in y divided by the change in x. And tan theta is also opposite by adjacent. So remember that tan theta is equal to opposite by adjacent, which happens to be the change in y divided by change in x, which is dy by dx, which is 2. So dy by dx is in fact 2 over here. That is what you needed to figure out. See this? Theta del y del x. So tan theta equals to del y by del x, which is 2. Now we know that dy by dx is 2k, 4x plus 1 to the power minus half minus 1. So k is 10.5. 2 into 10.5 is 21 times 4x plus 1 to the power minus half minus 1 is equal to 2, or 21 4x plus 1 to the power minus half equals to 3. So 4x plus 1 to the power minus half equals to 1 by 7. And finally, after cross multiplication, we actually get, this is basically 1 by root over 4x plus 1, right? So 7 equals to root over 4x plus 1, or 4x plus 1 equals to 49, 4x equals to 48. I squared both sides. 48 by 4 is 12, so x is equal to 12. Now we found the x coordinate, but we need the equation of the normal to the curve at that point. So since the gradient dy by dx is the gradient of the tangent, so what will be the gradient of the normal? It will be minus 1 by 2. And we need the y coordinate now. How? Using this. Y is equal to k root over 4x plus 1. Y is equal to k root over 4x plus 1 minus x plus 5. So we end up with y is equal to 10.5 root over 49 minus 12 plus 5. So we end up with 10.5 into 7 minus 12 plus 5, which is 66.5. So let's find out the equation of the normal. Y minus 66.5 is equal to minus half x minus 12. So 2y minus 66.5 into 2 is 133 is equal to minus x plus 12. So 2y is equal to minus x plus 25, or y is equal to minus half x plus 25 by 2. Anything works honestly, but that is our final answer. So yes, difficulty wise, a lot of candidates have been saying that this variant particularly was probably the hardest variant for pure math paper 1 for the last 10 years, in the last 10 years. So it was pretty complicated. Anyway, that is it for today. Hope I could help you guys. Quick shout out to my top tier patron Pearl. If you guys want to shout out, you can consider supporting me on Patreon. It's patreon.com/CAI paper solved, where you get access to notes for science, um, help in text and video meetings if you subscribe to the highest tier. And yeah, subscribe to the channel if you like the content. I'm gonna link the playlist for Math P1 up here, and the paper for May June 2023, paper 1-1 when I solve it, as well as May June 2023, paper 1-3 down here. And subscribe to the channel. See you guys.